Hello friends, सबको namaste. So today in this video we will create a behavior detection using a YOLO model. Okay, so before that let me upload my zip file from my Google Drive. Okay, so how can I do it? Just copy this link and paste it here and keep this part only. Okay, this part only, and just give your file name, output file name, and just download the zip file from your Google Drive. Connecting from GPU or a CPU. Wait for a minute. It's done. See, it's downloading. Now we have to unzip it. Make sure that your this file name, and this file name should be same. And then you can see this. This is a zip file. And after unzipping it, say be a dataset. It's containing two folders, test and train, and one YAML file. You can know that YOLO basically work with YAML file because it through the YAML file it's come to know that where is training directory, where is test directory. Okay, and further information that how many number of classes and how many and which class is present. And but sometimes it might be possible that you did not get a YAML file while downloading the dataset from the from the websites. So we can create our own YAML file. For that, you have to use this data path, means the directory of your dataset, then a train directory, validation directory, and test directory. You can see that in validation I keep the train part, means in train same directory and validation same directory. Okay, because in this folder we do not have a validation folder, so that's why. Now we will create a behavior.yml file. This w is write mode as file, and just dump it. You will get this YAML file. Let me run this here. You will see this YAML file. Okay. Now this Ultralytics basically used for downloading the YOLO model. We have to install it. Now after getting this, we have to load the pre-trained model, and the model which we are using is YOLOv9 m.pt. Okay, you can see this YOLOv9 and the various model TSMCE, and each model is trained on 640 to 640 image size. And you can see this basically difference between them is the map, params, and flop. But most of the time we will see basically on parameters, and the model which we are using is YOLOv9 m, and 20.1 medium parameters is there. Okay. Now after loading the pre-trained model, we have to train it on our custom data set. How to train it? Just use model.train. That data is equal to beer.data, beer.pyml. You already know, I already told you that the YOLO model basically work with the YAML file, which give idea or knowledge to the YOLO model during training, that on which folder you have to go, on which where is test directory, train directory, and validation directory. And here epochs is 50. I don't want epochs to be 50. I want to be 5 because I already have a model which is trained on 50 epochs. After explaining whole code, I will upload that model and show you the result of that model. And image size 640. You can see this 640 here. Now batch is equal to 8, means I want when a number of images divided into the batches during training, I want in one batch 8 images should be there. And what is beer YOLO V8 here? What is recognizing here? What means when you will run this cell, you can notice that one run folder will be developed. Inside run folder, detect folder, and inside that detect folder there is one folder which name is be a YOLOv8, and inside that folder weights folder will be there, and inside that weight folder weights file will be there, means the file which saved during training. And yes, we want to save the model, and don't save every epoch. You can see this, don't save every epoch. What do you want? Means we do not want to save every epoch weight file. We just want to save the epoch file which is best. And patient is equal to 20 means early stopping if no improvement for 20. Epoch optional means, you can see this patient 20 means early stopping means you want to stop the epochs if there is no improvement after 20 epoch. There is no improvement in and loss or in the accuracy. Validation false. We do not have a validation folder, but validation folder here. But here during YAML file, while creating the YAML file, I already told you that I have kept validation with the train images only. You can do it, but I don't want to train validation. We don't use to. We don't. I do not want to validate my model during training, so I did not. I kept it false here. Let me run this cell. It will get started. You can see that. See, now training gets started. Now, this is a function through which I create a bounding box around the object, and here the object is bear animal. Okay, so images, I want box means the details, label, color sample, and you can see first I will create the image, copy of the image, then I will using this box variable I kept out, or you can say separate the x min, y min, and x max from this box using this map. Okay, and after an int here means all the is it might be possible that in box variable the values are in the float, but I want all values to be in int. Okay, so here I use int here, and here color sample is a list of the colors which is used for creating the bounding box around the object. I want to select one color among the list. Random selection will be there. Then I will create the rectangle around the object. Just pass the image x in, y bin, x max, y max, and then color, and 5 here is a thickness. Now I will put the label, means means whether it is means the where is there or a background will be there. Okay, you can see label means just pass the image label x min y max plus 40. What is it is here? It is representing x min y max till here. Till here, you can see that x min and y max is representing the bottom left corner. Okay, x min y max is representing the bottom left corner of the bounding box. But I do not want to just display the label just below the bounding box. So I have to add some padding here. So that's why I use 40 pixel. Then this is a font. This is one is basically the size, then the color, then the thickness, then the color CB line A4. Then after that we just return the image. Now let me run this cell. Now you can see this run, detect, the folder name which we have created, which we have given, then the weight, and you can see the inside that weight file two weight file will be there, best and the last, and we want to use weight best here. Okay, now text image directory means the folder where the test image is there is beer dataset and test. You can see this beer dataset test. Okay, now this is a color sample. I told you that there is a color sample, is a list of the colors to display the bounding boxes. Now first I have to create a list of all the images in the present in the text directory. Okay, so just give the ls list as directory. It will create a list of name of all the images present in that test directory. And I was just want to display 4 rows, 4 columns, means 16 images I have to. For that, it should be have 4 rows and 4 columns. Okay, and the each size will be 16 by 60. Now, so to display 16 images, I have to iterate 16 times. So that's why 4 IDX in range 60. Then I will select random file name, random image file name. Through this random choice from image file list, the list which I have created above. After that, I will just create a directory. For the creating the directory, I have used os path.join, then test image directory, means this one. After that, I have to give the file name, which completely give me the image directory. After that, just give the image, means we have to read the image. And here just see here I am passing the image path. Even you pass the image path or the image after reading it, there is no error will be there. All will be fine. Both things will be get fine. No error will be there. Now, what is the use of zero? Because I am just passing the one image. So to retrieve the information of the model after predicting, so I have to use zero here to get the first image results, or you can say the information after predictions. Okay, now what is the use of result.boxes? Why I'm iterating over here? I'm iterating over here because it might be possible that multiple animal display on a single image, or it might be possible that on a single image multiple bounding boxes will be there. So that's why I have to iterate over result.boxes, then box, and box contain the information of bounding boxes and the class ID, you can say. So I have to retrieve it. I already told you that what is the use of map. Map basically box.xy give the information. Zero here basically is for the single image, because I am passing the single image, and xy is means the image is in a xmin environment xmas mymax format, and I have to retrieve that information. So I have used map, and it will store all the information in this xy variable. After retrieving it, I have to retrieve the information of classmate, which class ID it is. And after retrieving class ID, I want to know the name of that particular class ID. For that, I have to use model.name, just pass the class ID, and I will get the label. After that, just pass all the information in draw images. You will get the image with bounding boxes and the label. And you have seen that images is read in a CB2 form, read by the CB2, and CB2 read the image in a BGR format. To have to convert that into a BGR to RGB. So here I am converting it. Then I am show the image and just plot. So let me see my training is cat over or not. See, to training cat over. Now I can easily, it's not over yet, so wait for that. Now you can see that see, in fifth epoch, you can see this, it is displaying the information of bounding box loss and classification loss and DFL loss. And you can see that we have total images of 1521, and here you can see it is having a 191. So how it is coming to 191? You can see this. We have chosen 8 for the batch size. So when 1521 divided by 8, you will get 190. Okay, if suppose I will use 190 into 8 is equal to 1520 image, 1520 images is there, but one image is getting left here because we have total images 1521, and that one image is shifted to 191 image batches. So here 191 is representing the batch here. Okay, so this is the informations. So now let me use that model which is trained on 5 epoch, and let me show the result of that. See, it's pretty good, but not that much. Now let me upload my model which is trained on 50 epoch, and let me show you the result of that model. Okay, so let me come back when the uploadation of that model get completed. Now see, you can see the uploadation is completed. Now let me show the result of the model which is trained on 50 epochs. So this is the result of the model which is trained on 50 epoch. Okay. So you can change the epoch value above, and you can download the model which is trained on more than uh, on more than 5 epochs, and you can increase the accuracy by that. Okay, so now you can download the data model and use anywhere you want to use. So this way the explanation is completed. So please like, share, and subscribe. Thanks to all.